express the fraction into the partial fraction. So for the first step, we're going to check whether it is proper or not. So for here, this is quadratic. And then denominator also quadratic. When we're having a fraction with same or with the higher power at numerator, pengangka dia lebih besar ataupun sama dengan penyebut, so this is same ranking, quadratic over quadratic, means this fraction is not proper. So when we having a not proper fraction, or we call it improper, when we having an improper fraction, it cannot straight away proceed to partial fractions. So for these improper fractions, we need to undergo long divisions. So let's just simplify the fraction first to the proper fraction, then only we can proceed to partial fractions. So we have to divide it. We have to do this polynomial division by using long division. So divisor here is x squared minus 4. So how to divide this? You can see you need a value of 2. 2 divided by 1, so you need a multiplier of 2. So x you no need. When you expand, 2 times x squared, 2x squared. So expand for this 2 times negative 4, you get negative 8. So negative 8 is at constant, so I put at constant place. So make sure you're doing long division, your terms is in order. X squared followed by x followed by constant. So 2 times 4 is a constant, so I put here. Then we find the balance here. We find the remainder here. So 2 minus 2x squared, 0. This one, negative x minus nothing. So it still have a negative x. Then 6 minus negative 8. Negative become positive. So we have a 14. So do we need to continue our division? You can notice that this is linear. This is quadratic. So linear can't be divided anymore by quadratic. So linear is smaller than quadratic. So means that this linear will be our remainder. Then we write our long division here into the answer form, where a polynomial divide with its divisor, it will equals to its quotient, which is 2, plus remainder negative x plus 14 over divisor. So this is the way to write our result of our long division. So from here we can notice that now from these improper fractions we already finished simplifying. We already finished division here. So this is new pattern of our fractions. So only a proper fraction can undergo partial fraction. So means the remainder part here can be undergo partial fraction. So from this remainder part, you can notice that numerator linear, denominator quadratic. So this is a proper part that only can proceed to partial fraction. So first step, we managed to find its proper fractions already. So second, we have to make sure the denominator divisor here or denominator here is in completely factorization. X squared minus 4, it can be factorized x minus 2, x plus 2. So our denominator here should be in the factor form. Then we continue for the step number 3. We're going to split according to its factor. So one of the factor is x minus 2, another factor is x plus 2. Then going to determine its numerator. When you have a linear, so up here will be a constant. So this is also a linear factor, so here will be a constant. After that, we form the equation about our numerator here, where a will be need to time with the factor that it don't have, which is x plus 2. B, we're going to time with is the factor that it don't have, so x minus 2. Then we have to find AB, so we can let this time let x equals to negative 2, because I can see one of the root is negative 2, another root is 2. I have two unknowns, so I have to let it 2 times in order to find out these two unknowns. Substitute. So you'll notice that here we'll give a 0. Continue when x equals to 2. So 2 plus 2 will equals to 4. Then 2 minus 2 here will be 0. So A will be equals to 3. Lastly, we're going to substitute into our partial fraction. But this partial fraction is one part of from here only. Our original fraction is this. So we have to write back starting from our original questions. Our original question is this: 2x minus x plus 6 over x squared minus 4, which is equals to 2 plus the proper fraction expressed in its partial fraction way will be A is 3, and B is negative 4.